welcome everybody. So I'm happy you are here. So thank you. And also thanks to Jason and to the RISE team for having me here. I'm excited. I tried to do my best to distill my knowledge into this presentation. So I hope that it will be useful for you. Probably it will help you to better solve some of your working tasks. Probably you will get some better intuition about LLM Evals. I will be happy with that. But I will also encourage you that this is an open discussion. It's an interactive talk. If you have some questions, feel free to ask, and I will be happy to answer. All right. So I will start from the description of what I do and what my team does. We'll list some projects we are doing, and we will dive deep into the project about customer feedback tagging and how we use evals there. And separately, I want to tell also about how evals insights helped us to build a better architecture of production system. And also some general findings and practices from evals in industry. So what about me? My specialization is deep learning with a focus on NLP. So currently I'm working in the Wayfair and I live in Berlin. I also engage in community activities. So as I said already, I'm organizing a series of applied AI meetups. And also I love teaching. For example, a year ago, we did a summer school in language models in the University of Oxford for computational social scientists. About Wayfair. So Wayfair is a US-based e-commerce company focused on home goods. As you can see, we have a lot of data. And we have a lot of space for machine learning in different areas like NLP, computer vision, tabular data, time series, whatever. And my team is called Product and Content Intelligence. We build data-driven solutions for both supplier experience and customer experience. Some of our projects. First, it is a customer feedback annotation project. So each incoming comment, where it is a customer review or return comment or something else, it goes through the customer feedback annotation model that predicts the feedback topic. We have a predefined taxonomy, as it's shown on this slide, with several areas of several levels of hierarchy. Like first level is the broad topic, like product, customer, service, something else. And then we have theme, sub-theme, problem, and location. And model can predict one or more.
And good question for you on the previous slide.
Yeah, go on.
So how are these used in your organization? Does your service team then look at them and look at the labels and does it route to different people? Or...
Yeah, exactly. So the idea is that when we automatically get very fast the feedback topic, we can direct it to specific managers and to solve problems faster. Yeah.
And was it kind of, is there a current model today kind of doing this labeling for you, or is it people or like human labelers or a little of both?
Yeah, so I think before the model, it was only human labeling and it was costly and it was a long time. So right now it is a model, but also we have some continuous human in the loop monitoring pipelines to make sure that model still performs good. It works on some like relatively small amount of data, but we still, it solves the purpose to make sure a model is healthy. Yeah.
Got it. Cool.
One more feature I like very much is what we call bubble filters. So we have a model that mines aspects from customer reviews, and we provide users with the opportunity to filter reviews based on selected aspects. We also previously open sourced our model from the paper. And this is an example of a multimodal project, which is about product tagging. So we extract different tags from both product descriptions and images, and enrich search experience with different filters and some other features.
Interesting. On that one, there's a model that essentially extracts tags and information. And on these models, are you, one question I think a lot of people have is, are you considering, moving any of these to LLMs, or is that kind of debates within the organization? a lot these
Yeah,
days.
yeah.
What's ML versus LM?
Exactly, it's exactly what I'm doing right now. So LLMs and some vision models, vision
Yeah.
language models also show good potential.
Yeah.
There are still a lot of issues, but we are working on this. I think that probably my next talk would be like specifically about this, because we have like a lot to say here. Yeah.
Yeah. Yeah.
Good. So so going back to customer feedback annotation and other projects related to customer experience, we decided that we want to start experimenting with LLMs because before the discovery we had only separate models for each use case. And imagine we have a lot of deep learning models in production, and it is hard to maintain them and keep developing at the same time. So the idea that we had was that we could develop a consolidated domain adapted LLM solution that could cover at least some of our use cases, but better all of these use cases. And as you can guess, probably the current approach in the industry is that we have some foundational LLM, and we use parameter efficient fine-tuning methods like LoRa to create adapters for each use case, for example, for customer feedback, for bubble filters, and so on. So this is what we actually started to do. And some challenges we faced during this. So these are quite common, so that not deterministic output and hallucination. But what is more important is that LLMs are still understudied, and it's just not enough empirical observations what else might go wrong. So yes, we know that we might want to track hallucinations. Yes, we know that we might want to add some validation code to make sure output is follows the expected format. But what else? So we don't know what health checks we need to introduce to make sure a system is production ready, right? And also engineering challenges because we work with big models, so some distributed setup, some issues with GPUs, some issues with optimizing advanced pipelines, all this stuff. Some of the components we implemented, so components to fine-tune models with fine-tune and align models with modern approaches like RLHF, DPO, and so on. We also value reproducible science, so we took an effort to develop a framework for safe and reliable experiments with LangChain, MLflow, and some other components. And we developed advanced evaluation pipelines using Arise and Phoenix libraries. This is actually, from my point of view, a very important note from Greg Brockman from OpenAI that evals are surprisingly often all you need. And actually right now, there is no standards how to evaluate models specifically within domains like customer feedback or like any case in your company, right? So we had to pioneer it by ourselves. And let's dive into a case study, and I will show some results we achieved. So let's go back to customer feedback annotation model. So right now in production, we have hierarchical classification transformer model, so like BERT-based model, which is encoder, and it can predict one or more topics. So this is multi-class and multi-label model. It is triggered on each comment. So we have a service which is deployed and can respond with predicted taxonomy. And yes, as I already said, so it can be used for various sources of data. So this is quite scalable on our big amounts of incoming data.
And on this model today, to understand how well it's doing, do you actually do like human annotation on the results to track like is that kind of the flow today? Humans kind of check results.
So it's the same way. So we have some human in the loop pipelines for all our critical models. That's on some amount of requests. So we continuously have online monitors, which also some of them powered by Arise. Give us some real-time metrics, and we like build some reports to see like whether the model like the performance like drifted, whether the performance degrades, and so on.
Got it.
So and this model, I like and hate this model at the same time because it is very interesting in terms of machine learning and statistics, but it is so hard to maintain. So this would be like the first model I would like to replace with LLM. So
Question for you on that, like hitting that subject again, is the scale such that it could be replaced with an LLM scale wise?
Scale-wise, so right now, I mean that with the current model, so it is good enough. But if we want, for example, to some expand use cases to like give more flexibility to the model, it is hard.
Got it.
So we have what we have, yes, but with LLM, so as I will show a little bit later, we have some additional capabilities which we didn't think are possible with this model, but with LLM, it becomes quite easier.
Got it.
Yeah. And here is one more time this slide to remind you that the model predicts the taxonomy. So let's say model predicted that the comment is about the product, and we want to know if it is about the product, what is the theme? Is it about quality, price, or is it about color, about size? And this hierarchy goes deeper and deeper. Not always model can predict all 5 levels of hierarchy. Sometimes model can only predict the broad topic. Yes, this is fine. But of course, we want as much as possible. And here's how to approach this problem with LLM. So consider the prompt. You are given a text from a customer, and the goal is to classify customer feedback into the list of predefined topics. Next, we inject a list of topics and ask the model to choose all topics that are mentioned in the text. Do not add topics that are not from the list. Next, we can inject some few short samples. And finally, given the input text, we want the model to output with a list of predicted topics and some of the initial observations. So model doesn't always follow the expected format, so whether it is list, JSON, or something else, but this is what we were ready for, and we like wrote some additional code to post-process the output to make sure we can parse it. And but what was surprising for us is that models sometimes make up new topics which are not present in the existing taxonomy. But we explicitly asked in the prompt not to do it, but still. For example, model could predict style, however, it is absent in the taxonomy. Or model could predict delivery, but in taxonomy we have only logistics. Or model predicted difficult, but we have difficulty. And this was unexpected, but probably you can guess that it also may be useful. And we also thought that possibly presence of new topics can be beneficial for us because some of the topics may be useful signal to expand taxonomy, and with some other topics we can also think how to deal with them. And here comes Arise, actually. So here we used Arise Phoenix, which is an open source library for LLM evaluations, to help us to understand which of these new topics make sense and which not. When speaking about LLM evals, so one of the popular approaches is LLM as a judge. It is approach then when you have some LLM response and you want to say whether this response holds some certain properties like correctness, relatedness, like toxicity or something else, you can ask another LLM to respond with, for example, binary indicator like accurate or unrelated. And some another LLM can give you some response. And consider this template.
Question for you on the last one is was an LLM as a judge kind of a new idea, a relatively new idea to the team? I mean, I'm seeing some teams pick this up and do a lot of it. Is this something that like you kind of just heard about or were thinking about for a while and just decided to go do?
Yes, I think this idea, so I believe like in my team, so like everybody are aware of this idea, but so probably people don't use it like a lot because maybe don't trust much this. So yes, you can do some POC to do some examples, but I don't think there were like some serious discussions that this is what we potentially can use in production.
Yeah.
So yeah, this is a state. And this is, for example, how correctness template could look like. In this task, you will be presented with feedback from a customer and an extracted topic from an AI system. Your goal is to determine if the extracted topic is accurate given the customer feedback. So next we pass data and predicted topics and give the model instructions how to respond. So we expect from the model a label like accurate or unrelated. And we also ask model to provide a reasoning explanation why model thinks that the answer is accurate or unrelated, right? And let's look on some examples here.
And I would note there that on the previous one that like not all not all teams I see these days, like in your case, you actually have a different model judging the correctness of your original model, which isn't GPT-4, which I see a
Yeah.
number of teams do, but sometimes it's the same. A lot of times it's the same model. I get that question a lot. I see a lot of people use GPT-4 to judge GPT-4, for example, or Gemini.
Yes. So this is exactly right, that it can be same model, it can be different models. So
Yeah.
for us, what I showed here, that we used, we actually I like very much this model Zephyr 7B. This is a model which was trained on top of Mistral 7B with direct preference optimization by the Hugging Face team. And we actually started to fine-tune this model with supervised fine-tuning, with RLHF and DPO strategies. And on our data, it works quite good. So I can say that with carefully created data sets and careful fine-tuning, it outperforms on our data closed source models like GPT-4 or Gemini Pro.
Yep.
But for evaluation, we used GPT-4 because this model was not aligned so well. So it's like more like volatile.
Yep.
So I think that for evals, actually GPT-4 was showing good benchmarks. This is why it was our choice.
And there's a question from the folks here. So from a cost perspective, do you use a smaller non-fine-tuned model for evaluation and judging a model, thinking more from a cost perspective? You know, I think there's a couple ways to go. I mean, my gut on the eval side is probably start with something that you know works first. So the first thing is getting good results, and then back yourself out into maybe cost optimization. I'm not sure. You know, any thoughts? Did cost for evals come into the mind as you're thinking about this stuff? Some customers sample, you know, don't do it everywhere, but yeah, good question.
Yeah, exactly. So this is a very good question. Of course, we're considering costs.
Yeah.
And actually, so I will tell a little bit later about this, but we are not fully in production yet with this.
Yep.
So we're still doing exploration experiments. And so with this experiment stage, we can use whatever we want to try to find out what is the other bound we can achieve with current models.
Yep.
And later we can try to optimize it with smaller models. So this is possible. But for now, it is important for us to get the intuition is that like this problem is theoretically solvable with like state-of-the-art GPT-4. Because if not, it doesn't make sense to invest time in using some smaller model because probably we are not like in the state today to solve this kind of task.
Great question.
Yeah, I agree. Question is great indeed. Yeah. So and so answered this. So let's look on some examples of LLM judge evaluations. So let's read this first passage. These are a wash for me. The color was more like a pear green, not quite the color I was going for. Also, the one we put together wasn't easy. The screws are quite difficult to thread. I tried to have my kids do it to learn how to put something together, but I had to keep jumping in to help because they couldn't thread them. And let's look on some topics that were predicted by the model. Model predicts, these are new topics. So model predicted some topics from existing taxonomy, but also new topics. And here we look only on new topics. Model predicted use, smell, and taste. And LLM-based evaluator says that use is an accurate topic, but others are unrelated. And we can also read here explanations that says that topic use accurately captures these concerns as they all relate to the customer's experience while using the product. And I actually agree with this. So for me, explanation makes sense. I a bit truncated it, so later there were some explanations why these two topics are unrelated. So this was quite helpful. So just wanted to give you an idea. And I'll show you one more example, one my favorite. So let's read this review. Being the mom to 6 kids, I use a lot of different types of containers. The Rubbermaid container is amazing. Not to mention you can use it in the microwave plus wash it to your dishwasher. Very family friendly, and this mom gives a huge thumbs up. Very lovely comment. I genuinely love it. Could you think for a moment about some unexpected topic which could be predicted by the model here? Think for a moment. So you can guess something unexpected is going to happen here.
Oh,
But
wow.
the truth is that the model, for some reason, responded in Chinese. And this is what I could have never predicted. And I could never, could never think of something like this. Model tries to explain that it translates it from Chinese and says that it is unrelated. If we have here some Chinese speakers, please, you can let me know whether this explanation makes sense, whether translation is correct. But I think this is a good example of what I said, that there is no empirical observations what might go wrong, is that this is something I would never think of some kind of metric or monitor to monitor in production, something like this, because I could have never imagined this, yes, but still it happens. So this is very interesting use case.
This is, yeah, definitely surprising. And yeah, the explanation really makes it slightly more easy to understand what's going on. There's a question from the crowd here. The new topic detected, is that novel detection, meaning is it valid or just a hallucination? Should we evaluate so the first question is like, so it's basically a new topic. Is that kind of not, do you feel like it's novel, meaning is it valid? So do you think this topic was valid?
Yeah, so basically, so good question.
Or
So
hallucination?
we have as output list of predicted topics, and some of the topics, they are from our predefined list.
Yeah.
And here we only made separate analysis for topics which are not from the list.
Okay.
And we actually used this correctness evaluation to check whether this new topic makes sense. Is it related to the review? Yeah.
Yep.
So yeah, this is how. So from my point of view, from my point of view is definitely not valid.
Yeah.
Yeah.
It's definitely it definitely seems like it's definitely out of the range of topics you have, so it's hallucinated, and then definitely hallucinated in a way that is probably irrelevant to, not helpful.
Yeah. So correctness here is one of the labels. So for sure, I think so. This topic also could be filtered by any other meaningful metric, but still just curious why this happens.
Yeah. Another question here was, should we evaluate hallucinations for kind of their the creativeness or creative categories? And I think that's kind of what you're doing here. It sounds like you're trying to look at things that are not in your expected labels and evaluate if you should add them, kind of.
So this also, I think, one of the takeaways actually from LLM Evals, from my experience, that you need to design a set of evals for your task to find out what you really need.
Yeah.
So so no standards yet. All right, so we go on, right?
Yep. Cool.
Okay. So yes, so now we observed that the model can make up new topics, but given this, we need to decide how to deal with it. One idea is that some topics may be very similar semantically. In that case, probably we can merge them in some of the existing topics. For example, let's say model predicted delivery, but we have logistics. The meaning is very similar. We can compute quotient similarity between embeddings of these two topics. And if it satisfies our threshold of similar items, we can merge delivery into logistics. So this is how we could still get a precise result which correspond to our predefined taxonomy and meets expectations of our stakeholders.
Yeah.
On the other side, some topics may be very dissimilar. For example, let's say model predicted portability. It is not present in the taxonomy. And we can compute similarity between portability and all other topics. And if we see it is very low, that maximum similarity for any pair is less than our lower threshold, we can say that this topic is very unique. It is not similar to anything we have. This is some new signal from a customer, which probably we might want to monitor in the closest future. We can mark this topic as a potential candidate for taxonomy expansion, and think what to do with this a little bit later. Does it make sense, right?
It does. Yeah.
Next, we went to discover more about similarities with visualization analysis. So we applied embedding model. We used Distilbert, fine-tuned on customer reviews, applied it on predefined and new topics, and projected it on a three-dimensional space with the help of interactive Rise Phoenix tool, which is great. I like it very much. And here we have that pink ones are predefined topics and the green ones are new topics. And let's explore some clusters a little bit closer. So we take some near neighboring points. And here we have a new topic is text message and predefined topics like email, phone, chat, SMS. So probably we can merge text message with SMS or chat, right? So next we have here different price versus found cheaper price, which also somehow related. And some more examples. So here we have difficult and difficulty, definitely should be merged. And this is a big cluster. And as you can see, it's also related to very similar things like damaged, defect, conflicting, incorrect, error. And also like most of these can be somehow merged together. And this also can help to improve the coverage of our model.
Is it in this case, are these the LLM, the new LLM model you're testing in the generations of the new topics?
So this was I think this came from that very same Zephyr 7B supervised fine-tuned.
Yeah.
So it's not the best our model. It's one of the models I took examples from.
Yep.
Yeah.
Got it.
So what are the key observations? So the main thing for us is that we were able to predict topics from our existing taxonomy with required metrics because we have ground truth reference and we could compute it directly. So we were happy with that. And also we found out that LLMs are able to create these new topics. And LLM Judge helped us to distinguish between related and unrelated. And also what was important is that topics are semantically similar, so meaning that we can merge a lot of them. And explanations also were making sense most of the time. It is very convenient and helpful then, so in the very early stage of experiments, you just get some samples and you have to look manually a lot to understand how model performs in general. And this is super helpful, and it helps to boost how you look up with and how you make some actionable insights. What's more, so some topics were tagged as unrelated, and we assume that LLM Judge could still make some mistakes. So it is still important to keep monitoring here to make sure that some useful signal is not lost, and we have a control over this flow. And one more insight is that as you saw before, we have as a prediction a list of predicted topics like service, product, customer, for example, yes? And it is better to ask LLM Judge separately for any topic, whether product is correct, whether service is correct, whether customer is correct. Because if we pass this list in at once and try to ask model to respond, for example, also with list of Boolean values, it will be more complicated for the model, and model can give poorer results.
That's a question here from one of the audience again. It's really Sanjeev said, how do you deal with guardrails here? Do you set and let me read the whole thing because it's you'll get what it is. Do you set creativity to 1? And she's asking about like the analogy to healthcare would be diabetes data used, and you end up finding answers to breast cancer. So her question's like how much do you keep everyone in topic versus allow allow it to go outside of that topic range, and what's the how much do you try to dial in the LLM to stick on topic, or how much are you okay with it going off topic? And just question, I think.
Yes, I think so. This like false positive issues and some like the cost of errors differs from use case or to use case. I think for like medical use cases, it's very different from what we have here. So these use cases is quite convenient because it is not customer facing. So even if we let go some weird topic, so the worst that might happen is that some manager will be confused. And this is not super well, but like we can let it go, let it be. So we can later just fix this bug. But because this is used for, this project is for internal usage of our managers, this is a little bit easier for us. But generally, yes, I think that like next level would be that to introduce more evaluators and make sure that everything is like super accurate. And especially for medical, so I think that to design experiments for medical domains, so you should also like think a lot about set of evals you really need to check to make sure that the application is robust and safe. Yeah.
Yeah, and I would add on that one note is like we found like different models kind of follow instructions a bit tighter. Some are looser, some will be tighter. So like a GPT-4 might really stick to the set, where a different model, the original Claude 2, for example, would just wouldn't stick to the set and would talk a lot. Like you'll find different models will, different models you choose will follow your instructions either tighter or looser, I find as well. And you probably, and typically in the prompt, you might be able to dial, in those ones that follow it really tight, you could also dial it back in the prompt. Like, if you don't think it fits the category, suggest a new one. Things like that you can do to let those that really tightly follow instructions to open it up.
Yeah. So I think yes, I totally agree, and I think that
Yeah.
it's not only about prompts. It's like it's a big system, like from
Yeah.
different components, and you will need so to make it precise, like to work on different components. I think that also what would be very beneficial is that if you decide to fine tune your model to like carefully create the data set, so data really matters. So, like it super helps to align model.
And is your view, maybe the evals help you as you decide this fine tune versus this fine tune, you now have this correctness measure to understand if you broke something in process?
Yeah, and
Yeah.
evals also helps to identify some issues. For example, you can find out that, let's say here model for some reason responds in Chinese, that probably you could add to some data points with labels which addresses these particular issues. So this is actually also how evals helps.
Yeah.
So this is an iterative process that you like find out some issues and you try to create more data labels that will fix the model in this use case.
Cool.
Okay. And here is the expected system design. I say expected because we are not fully here yet. So we are not productionized yet because we are a big company. And on our scale, it takes time to speak with stakeholders to make sure everybody are okay with the new solution. And we still have some steps to do. But this flow helped us to identify how a production system would look like in the closest future. And here, let me explain some key components. So there is an LLM endpoint which can generate predictions, and it is connected to adapters storage, which are fine-tuned weights. We can like connect with the foundation LLM and make predictions with respect to given use case. So once we get predicted topics, we can pass them to LLM evaluation processor. It evaluates it with we already discussed so far, like correctness, toxicity, and so on. And also it separates topics into the ones which are possible to merge and the ones which should be considered as new topics. The ones which can be merged are later post-processed and written directly to the customer feedback database, while new topics are sent to the taxonomy expansion processor. It mines statistics about occurrences and frequencies of different new topics. And even if we see that some topic some topic frequency is like it happens quite a lot of times, we can actually update our taxonomy in the runtime. So this is how like automated taxonomy would look like. Is there some questions?
Yeah, there's a question on the system design. So instead of a full-blown LLMs, any thoughts of using like encoder-only models in particular stages of the pipeline?
Yeah, so actually, this is how it works right now for us. So right now we have only encoder only model. So this is but the issue is that so why we have right now encoder model, because we solve a classification problem. And why we solve classification, because before LLMs were invented, the business wants us to like extract as many topics as possible, but we don't have very powerful model to extract any number of topics. So we had to create this taxonomy with 85 classes of topics. So it is not what, it was not perfect business decision. It was just because there was no other way to build models with it. But now with LLMs, with the possibilities that we can like get new topics for free, yeah, we can think about this different way, and we can expand taxonomy. And this is actually what we wanted for a long time, because the signal from users changes from time to time, and it's really cool to be able to update this taxonomy. So encoder models can be used on some like stages, and for example, they actually under the hood here also. For example, then the computing similarities. But we found out that generating from with like LLMs can help us very much here.
Great.
And finally, let's discuss some general findings and things about and challenges about evals that you should know. So firstly, it's important to understand the difference between model evals and task evals. So today we discussed the latter. So task evals are used by ML practitioners for specific production use cases. They should mimic real world scenarios. They should reflect dynamic changes of your application, and you iteratively apply these evals to make your system better in order to finally deploy it to production. While model evals are used by LLM researchers to test general capabilities of the model. So when you can look on model evals when you choose a foundational model for your application. So for example, if you're building some chatbot, you can be interested in some chat metrics, and you can see how model performs on like some public best known chat benchmarks, right? But once you decided to choose some foundational model, so you should design task evals.
Yeah, and I was dropping out like MMLU, if any of you have heard of that, or HelloSwag, or there's just well-known benchmarks that I saw the Llama 3 metrics drop today, for example, and MMLU was at the top, and so these are all the model builders trying to help you figure out what try to show off their model for you to go choose.
Yeah, exactly. Yeah. So one more interesting topic here is that when you use LLM-based judge, it is safe to ask model to respond with a binary label rather than to ask for a numerical score. So you can read this research. And this is also a well-known thing because LLMs are not good in numbers. So better to use binary or some categorical indicators so far.
Yeah. And I think our recommendation on this one is just kind of stay away from the continuous. A true range, and the worst range is like 0 to 1. So like they're really bad at fractions. Fractions are or decimal places are multiple tokens, and they're just probabilities are horrible. So category binary or multi-class for an eval, it's what we recommend.
And they also, some numerical ranges, they also can be quite subjective.
Yeah.
So the model can treat it very differently. So it's just like not calibrated. A very recent paper, which went like maybe a week or two ago and attracted me very much, was this one. So guys asked a question that that it is actually very hard to detect errors in LLM responses in general, because a lot of tasks in NLP are very subjective. And for some tasks, even for human, it is hard to precisely estimate whether it is correct or not correct. And for LLM, of course, it's even harder. So consider an example. So summarization, I think, is an example of a quite subjective task. So recently there was a post about Amazon product review summarization algorithm. It turned out that Amazon algorithm was mischaracterized products, and it was biased towards negative feedback. And of course, suppliers were not happy with it. And we had quite similar experiments in offline settings, and also like facing issues here. For example, can imagine that you are sending to the model like 100 product reviews about particular product and asked model to give a summary. Model responds with like very concise and good looking text. And it is hard to say that whether it is like relevant or not relevant. If you ask like a number of people, probably people will decide differently. So I think this is a very hard use case for like LLM Evals. And for these use cases, you should be like very careful and also think a lot how you evaluate it before you go to production. Are there some questions here? Some Amazon people here?
Yeah. So there's a question, observations about LLM's inability to classify based on numeric range has been consistent finding in some of the series presentations. Really cool to see the topic approach. Okay. In multiple domains. Yeah. So yeah, definitely put out a good set of research on this. And yeah, our one note is I feel it every day that the LLMs just continuous ranges are not represented well by architectures we have today.
Yeah. So, and continuing about this paper, so guys introduced an evaluation benchmark for LLM responses error detection. Their insights were that even top LLMs like GPT-4 still like detect errors with low recall. I think this is very important call out. Firstly, like existing, so creation of this benchmark is very important to boost designs of LLM Evals. And yeah, so it's good to know that still there is a lot of room for improvement here. So we need to take this into account.
Awesome.
So some questions, no?
Let me the couple that dropped. So it says, have you tried to use cheaper models for eval or compare their quality with GPT-4? And with GPT-4 costs can be really very high. We do it. So in Phoenix, if you go to the Phoenix open source library and go to the evaluators, there's actually a bunch of models for each predefined template. There's a test suite of models we've done. So there is there's examples of GPT 3.5 and depending upon your task, you can get away with the lower class model or not lower class, lower parameter model, previous generation. So we would typically recommend build a data set and then probably get it working first and then use that test data set to evaluate your evaluator. That's probably what I would say. Have you yet backed out to like a 3.5 or something yet? And you're just kind of trying to get it to work right now is my take.
Yeah. So actually, we also were referring to benchmarks from Phoenix. That also like GPT-4 like now is so far like probably the best.
Yeah.
But I agree with the point that later, so you can also fine tune some smaller model and use it. I think this is also the future. So right now it's very important to understand how to productionize it as a big system, and later you can optimize some components of the system. So this is it.
Yeah, and it says the question here is one other question here is have you tuned Zephyr and have you fine-tuned Zephyr and what was the data set like? Trying to get an idea of how much effort you had to put into it, how big was the data set? So a little bit on your fine-tuning question.
Yeah, so we did fine-tune it. So actually, it is not so hard as it may sound. So we didn't even have like a lot of GPUs. So probably one machine with 8 V100 Tesla, I think was enough to run it in the like PyTorch distributed mode. So I think you can. So when you just so I think that if you take a data set, so it depends on the task. But if you take a data set with let's say 10,000 examples, you will see the difference. So already on this, and you can train such a model like during one day, so it will finish training, and so you can see some like first results, and later you can see like whether you need more data, whether you need to like maybe add alignment step, and like do something else. But I think the magnitude is a try with 1,000, 10,000, and see whether you need more. Okay, so we are close to the end here. So what I want to say is that domain-specific tasks evals, as you can see on my example, can help to design the system, can help to find out some actionable insights. This is very useful. And designing a set of evals is a work of art from my point of view. It requires some creativity because you don't know in advance what you need to monitor and how each metric can correspond with some like your key objectives. And I have never seen how that research and industry we're moving so fast in comparison with today. So it's very exciting. And even probably that's something I'm saying to you right now is already outdated. So I'm excited to see that what will happen next. And I believe even from LLM Evals, we can expect much more like in the closest time.
Yeah.
And finally, again, we'll repeat this thought that there is no industry standards yet. So be the one who make it. So engage in discussions, engage with communities, give public talks, share your insights, and help to move the community forward. So thank you very much. I'm happy to
Awesome.
answer your questions and hope you didn't regret to come here.
No, great questions, everyone. Yeah, and we do have a SQL, generation eval, event coming. I think we'll be scheduling a couple more sessions of these. So thank you, everyone, and we'll be putting out more. And then there's one more question here. Just curious, did you guys use model parallel or data parallel DDP with PyTorch? Maybe it's talking about fine tune.
Yeah. So DDP was enough for us. So because when you use, so even if we use 7 billion models, and generally 7 billion models, they fit into V100 GPU. But yeah, so if you use like several machines, but if you use, for example, 70 billion, you would need to do model parallelization because it would not fit. But for us, it works quite well. I'm not sure we need to do right now something with 70 billion models. We are okay with 7B. Yeah.
Cool. Well, thank
So
you.
basically, yeah, so always, so I like the topic about distributed computing. So basically all the stuff in Hugging Face, so I like have a look on Accelerate library, which can also make things easier. So these are nice things that can help. Yeah.
Awesome. Well, thank you all for joining. Thank you, Ilya, for the awesome presentation here. Yeah, like try get out there and try some evals on definitely use evals if you're putting LMs in production. That would be my 2 cents for everyone.
Yeah, thank you very much. I also enjoyed. Yeah. So thank you, guys.
Great. And hey, Sarah, where are we gonna? I think we'll be sharing the deck. We'll share it in the community. So within the Arise community as well as email, we'll share the deck here. Awesome. Thanks, everyone.
Bye-bye.
Bye.